That was lovely. Okay, there you go. Okay, so number 6. The nucleus contains most mass within an atom. Why? Because it's the densest. What two particles are in it? Protons and neutrons. Protons and neutrons are heaviest. Okay, protons and neutrons are heaviest. The atomic number is equal to the number of blank and blank. So what is the guarantee? So what is the always? I'm going to put the word always underneath it. Protons. So put that on that first blank. Protons always. And electrons. What does it have to be with the electrons? It's when it's what? When it's neutral, right? So we can say when neutral, or you can say when not an ion, which is what we were just working with. When not an ion. I'm going to zoom in because you guys totally can't see that very well. There you go. Not an ion, not an ion, but sorry, there should be 2 words here. An ion. All right. Okay. Are we all good with that? So your guarantee is always who? Protons. Good. All right. Number 8. Describe the current electron cloud atomic theory. All right. So we are actually not going to describe it, but please put the word quantum. Quantum model, because you might see that word tomorrow. Okay? I did my best to change it always to cloud, because that's how we learned it, but if you happen to accidentally see a quantum, that's what we're talking about. All right? And so verbally, I'll just tell you the quantum model or the electron cloud model takes it out of those orbits. They're still at energy levels, but they're very sporadic, and it's an organized chaos in that electron cloud. All right? So they're just constantly moving. All right, number 9. What is the meaning of the term isotopes? Let's just define what an isotope was. Same number of what? Or same what number? Same protons, which is, hold on, before we do that, which means same what? Atomic number, good. Different. What is different? Neutrons, which affects what number? Your mass number. So same number of protons or atomic number, but different neutrons, which means the mass number is different. Okay? Number 10, describe the 2 particles which can be found in the nucleus and give their respective charges. So we already answered that kind of, but what 2 particles? Protons, which is a +1, and neutrons, which is a 0. Okay? So this is protons, this is a +1, this is a 0, because that looks like pH, and we are not in acids and bases yet, so we're talking about pH. That is a +1 charge, 0 charge. What's their mass? I'm pretty sure we're going to answer that in a second, but let's just go ahead and say, what is the mass of each of those?
I just know it's around.
They're 1. They're both 1. Okay? That's why they're the ones that kind of count towards our mass number. And that's why we're able to count them up. Okay? Electrons add a little bit extra, and that's about it. Okay? All right. We're going to go all the way to 12, and then I'll start a new video. So number 11. Describe the relationship, quantify, between the number of protons and electrons in an electrically neutral atom. How would you explain that to someone who has no idea? They're the same, exactly. Protons and electrons are the same. I'm putting exclamation points, not to yell at you guys, just you guys are yelling at yourself. All right. Number 12, calculate the number of protons and neutrons in an atom of plutonium. So you got to have your periodic table. Make sure tomorrow you have a periodic table ready to go, okay? So plutonium, they may know where that one is. Down at the very, 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 very bottom.
I found it.
Winnie the what? Who's the bear? I was trying to get you guys to say poo, because that's what it looks like. Winnie the Pooh? No, okay. All right, that's good. I was trying. Or we could do PU. All right, yeah, so that's our chemical symbol, right? And so we're going to write our little isotope notation, and then we'll get that information, right? So plutonium has Pu. What is the atomic number? 94, so that goes on the bottom. What's our mass number? 239. We get that from here, not the periodic table, right? That one says 244 on the periodic table. That's not what we're using. We're using the one that's given to us about our isotopes. So 239 goes on top. Now we can go ahead and say protons, neutrons, and electrons. All right. So my protons are equal to what number? Atomic number, right? So 8, that's the 8 part. So 94. Is this a neutral atom? Yes, because there's no charge right here. Do you guys see that? Since there's no charge, it's also, so what does that mean the 94 is also going to go for? The electrons. Good. All right. And then our neutrons, we're going to get from doing our mass number minus that 94. So if you have a calculator, can you help me out with that? What'd you get? 145. 145? Okay. Awesome. 145. All right. Are there any questions on 8-man?